Hey guys, last time I showed you how to set up Unreal Engine and get a template project up and running so we can play with some values. This time I want to show you how to actually use the first person template to make our own little mini game, which is going to be a target practice type game. And instead of using the default first person projectile, we're going to switch it over to hit scan, and we're going to create our own little target objects so we can keep track of score, and maybe we can add a little button that the player can walk up to and press to restart the round. So the first thing we want to do is start on the blueprint tab, first person template, just like last time, or you can use the same project as last time. Make sure it's on desktop, maximum quality, and definitely need starter content because that's what we're going to use for all the 3D models and materials. I'm going to name this target practice. The first thing I'm going to do is just open up my file view so I can see all the folders, and I'm going to make my own folder called my content. Not in there though. I'm going to put it in, make sure content is highlighted, new folder, my content, and I'm going to make a new level, but I'm not going to put it in the main folder in my content. I'm going to make another folder inside here called maps. It's good to keep everything organized, like a maps folder, 3D models, textures, sounds, stuff like that. So in the maps folder, I'm going to make a new level by right clicking, going up to level, and I'm going to name this target practice level. Let's go into here by double clicking and go ahead and save. Now we can't see anything right now because there's no sky, there's no lighting. So the first thing we want to do is add a sky, and there's a sky object. If you search for sky, take the sky sphere right here, just click and drag into the world. Now we can see a little bit of what's going on. There's a sun over there. Let's change the sun height from 0 to 1. So now we got a nice blue sky. Let's add a simple square platform. So in the geometry section down here, take a box, click and drag it into the world, and we want to put this at 0, 0, 0 coordinates. So we can either manually type in zeros, or we can just click this yellow arrow to reset everything to zeros. And so there is the middle of the world right here. So now we know. And now I'm going to scale this up. I don't want to scale the vertical axis. If you click this little line right in between these two axes, the red and green, you can actually lock the blue one in place and scale the other ones. I don't know how big we need it, but we can just make it pretty big. And right now there is actually a texture being rendered on this, but it's so dark because there's no light source in the whole world. So first thing we should do now is add a directional light. This is basically a sunlight. See, it says hold Control Alt for more information. So the directional light simulates light that is being emitted from a source that is infinitely far away. This means that all shadows cast by this light will be parallel, making this the ideal choice for simulating sunlight. So we can just, again, click and drag, and the location does not matter. So let's just put this in the sky somewhere so it's not in the way. And if you wanted to, you can play around with the intensity, the light color, and you can change the angle. So let's change this material now using the starter content. Let's go into the materials folder, and again we just have to click and drag. I'm going to take grass, put it right on this face, and it's pretty stretched out because we started with that cube, then we stretched it out. So what we need to do is over here we can adjust the UV values, which are the scale, and we want to change these down to 1. That's like the default. So now the grass looks a little bit better. Now what we should do is add a player start. That's our spawn location whenever we start the game. Player start. Just click and drag anywhere you want, and then we can just reset the location to 0, 0. Then I'm going to pull the blue arrow just out of the ground. So now if we click play, we should have, just like in the first person template, we can jump around, shoot projectiles. So what I want to do now is duplicate those files that control the player and the projectile and copy them into my content and then adjust them. So we can go into the first person BP folder, blueprints. I want the character, I want the game mode, and I want the heads up display, but I don't want the projectile because we're going to make it hit scan. So once you have all of these highlighted by control clicking and right click, duplicate, let's just drag these into my content, move here, and in my content I'm going to rename these to my character, my game mode, my HUD. What we should do now is in the game mode class, this is going to reference which character to use and which heads up display to use. So what we should do is open up this and switch those values to our own files, which we're going to be adjusting. So there's only two things that we need to change here. The default pawn, we want to make this my character, and the HUD class, we want to make it my HUD. Exit. So this game mode is now going to reference our two objects. Now, in order to reference this game mode, to make this the default game mode, we need to actually go into the project settings. Edit, project settings, and then maps and modes right here. Default game mode. Instead of first person game mode, now we're going to use my game mode. And if we did everything right, we should see if we expand this, my character and my HUD for the top two here. Now, another thing we can do in the maps and modes section is change the default map to our level. So editor startup map is what's going to load when we open up Unreal Engine. And let's just have it go to target practice level. And game default map is if you export the game to an executable file, this is the first level that loads. Target practice level. And that's all we got to do. You don't have to click save in here, it's automatic. So let's just click play and make sure it all still works using our own objects that we copied. Looks good. Now the next thing I want to do is take out the projectile and switch it over to hit scan. So if we go into the my character blueprint, this is all the logic for the movement and spawning projectiles. So the white is basically a comment, and all of this is for spawning projectiles. So what this does is when we press a fire key, which is mapped to left click, when it's pressed down, the white executable goes to this, which plays the animation for the gun. Then after that, it goes over to here, which spawns a projectile. It takes in the orange location information from the location of the character and the gun. So after it spawns a projectile, then it plays a sound. So all we need to do is disconnect this input module by alt-clicking this. So now we can move it out of there. And now if we run the game, it's not going to do anything if we left-click. Nothing. So let's go back in here. So now what I want to do is set up a line trace system. So if you right-click anywhere, let's search for draw debug line. This is just going to let us draw a line in 3D space given the start location and end location, so we can figure out if we have the right calculations for our line trace, and then we can use that line trace to do more things after that. So when we press the fire key, take that executable wire, plug it into there. Now the start location, we're actually going to use the camera of the player. So because we already copied this, so it's already set up. So we can just take the first person camera. If you click it, you can see it's right here. And if we then go into the event graph, all we have to do is click and drag this in here, and then we can use this camera object to get information, like for example the location. So if you search for get location, the one you want is world location, and it's going to give us a vector which is going to be an XYZ point in space, kind of. That's going to be our start, so we can just plug it in straight to the start of the line. Now at the end, we're going to have to figure out which direction we're facing, and in order to do that, we're going to take this camera object and there's a function called getForwardVector. GetForwardVector. So this is going to be a vector that's length 1, and it's just going to be pointing in the direction that we're facing. But what we need to do in order to find the end is take the forward vector and add it onto the start location. That should at least get us started. So let's take a line off of the location, type in the plus symbol. Now we can get vector plus vector, and let's add that. Now keep in mind, this is only going to be a 1 length vector, so we're not going to probably see very much, but let's at least see what happens. So let's make it last for 3 seconds after we fire, and let's make it a thickness of 3. And let's make it red. So click this little box. Okay, let's see what it looks like. It's probably just going to be a little tiny dot. So yeah, there it is. So if you click without moving, you can't really see it because it has like no thickness on this axis, but if you move to the side, then you can kind of see that it's at least in the right spot. But we need to have it longer. So this forward vector, since it's only length 1, what we need to do is multiply it by a value. So let's type in an asterisk here, which is like the multiplication symbol, so we can find anything that a vector can be multiplied by. What we want to use is float values, which is like a decimal value. Let's just use an integer. And let's multiply this by 1,000, see what it looks like. And then instead of adding that forward vector to the start location, we're going to take the multiplied version. Play. Again, if I just click and stand still, we're not going to see anything because the line's going perfectly straight. But if I step to the side, you can see there's our line. So that's a length of 1,000 right there. Probably want it to be a little bit longer than that. So let's make it 10,000. I don't think we're going to have to aim at anything longer than that. But you don't want to make it something ridiculous like 1,000,000 because then it's going to take longer to calculate. So now we know that the line is in the correct location. That's the point of the debug line. Now, in order to actually make a line trace that can hit objects and affect them, what we need is a line trace. Just search for line trace. And line trace by channel is the main one to use. So let's just take the same start value that we plugged into here, which is from this module, the location of the camera, and the same end value, which is the location of the camera plus the multiplied vector, plug it into there. Now, trace channel, visibility, that means that the line can't go through objects, so it's going to hit just the first thing and then stop. Now, what this line trace function is going to give us, it's going to return this hit object. It's just a big object that has a bunch of information contained inside it. And this information is like the type of object we hit, the distance, the angle of the surface that we hit. So take this blue wire, and in order to break this open and take the information out of it, we need to actually break hit result. Now this is going to give us all these different values that we can use to do whatever we want. So remember from the first video that I showed you, red is booleans, like true, false. Well, I didn't show you green yet, but those are float values, which is decimal values. Yellow are vectors, so we can see like the location in the world we hit. The normal, which is the angle of the surface we hit. The physical material of the object we hit. So if it's something reflective, maybe we would use the impact normal to figure out which way to bounce the laser or something like that. But we're just going to do something pretty simple here. We want to say if we hit an actor, then we're going to destroy it. So just type in destroy actor, and we're going to take the executable, just go straight into destroying whatever the actor is that we hit. So let's put just a simple actor in the world, which is like a basic cube. So you don't want to have an empty actor because that's not going to have a 3D model. So you can just take a basic shape, and these have like a hitbox built into them. So let's play this. Now if we shoot this, it should disappear. There we go. Now we are going to get a bug if we don't hit an actor. it's still going to work, but after we close it, it's going to give us an error, which means we didn't actually hit anything, and it's trying to delete something that doesn't exist. So access none, trying to read, hit blah blah blah. So what we should do, the line trace module here actually gives us a return boolean of whether we hit something or not. So we're going to use this and plug it into like an if statement, which is a branch, it's called, so we can check if we actually hit something. So just type branch. We're going to take this executable, plug it into here. So if the hit was true, so if we actually hit something, then we destroy the actor. Otherwise, do nothing. So now we should be able to just click everywhere and get no errors. Yep, no errors. What we should do is make our own target object instead of using the basic actors. So let me just delete this. And then after we do that, we can actually check if the object is that specific type and not just deleting every actor that we hit. So I'm going to make a new folder in my content called blueprints. So new blueprint, actor, target object, double click it, go to viewport. Now right here is a list of all the components of our object. Every actor has a default scene root, which is what you attach all the other components to. So let's click this green button to add a component. We're going to add a 3D model, add a static mesh. This is a 3D model. And then we assign the static mesh to be a cube. There we go. Let's go ahead and put one of these in the world, our target object, just by clicking and dragging. I'm going to make it a gold cube. Let's actually make it a gold sphere. So I'm going to change this to search for sphere. And looks like there's two different spheres provided. So for some reason, one of these spheres, the shape sphere, is not actually centered on 0, 0, 0. You can see the center of the actor is at the default scene root, which is this little white thing. So what you can do is just either use the other sphere object to be more accurate, or we can just adjust. So let's change the location. It's probably some exact like 1.0 or 0.5. Let's see. Looks like probably it's 50. Yeah, so minus 50, so that should be on the actual center of the object. Otherwise, it's going to be a little bit weird. So there we go. So now that we already have this actor in the world, it automatically updates every time we adjust it. Still works. Let's make it actually apply physics. So in the static mesh, we can check simulate physics. Let's try that. So now we can probably like push it around. There we go. Now let's say we wanted to add some functionality to this object to increase the player's score whenever we hit it. So in order to store the value of our score, we're going to need to have a variable in our player keeping track, right? So in the character blueprint, let's create a new variable called score. So over here, click plus, and this is going to be an integer. So up here, change it to integer. It's going to be score. And click compile. That way you can adjust the default value, but by default it's going to be 0, which is what we want. So now, inside the target object, let's make a function just to show you how to do that, called hit by player. So whenever we hit it with a line trace, instead of just destroying it, we can actually do some functionality in here. So instead of destroying the actor here, we want to take this actor and we want to check if it's the correct type of actor. So you want to take a cast module. So cast to target object. So this is going to give us an executable if it worked and an executable if it failed. And if it worked, that means this object is a target object. Otherwise, we don't do anything. So if this worked, then we're going to take the target object and do something with it, like call a function. And that function is going to be the one we just made, called hit by player. So there we go. So now this function is going to be called, and now we can just go into here, hit by player. We're going to do the same thing, destroying the actor. Make sure it still is destroyed. Yep, looks good. So in the hit by player, we need to get the player, and there's actually just a function to get the player's character. Get player character. Now, just like we casted the object into a target object and got the function that we can use from that object, we're going to have to do the same type of thing here. Get the player character, we're going to have to cast this to our own character class called myCharacter in order to actually use the variables and stuff or the functions from that. So cast a myCharacter, and if it worked, so if the character that's being controlled is of that type, then this is going to be executed. And what we want to do is take the myCharacter, we want to get the score, type in get score, or whatever the name of the variable is that you're trying to adjust. So this is going to return the integer value of the current score. Now, we're also going to have to set the score after we add a value to it. So let's type in set score. Now, this one has an executable. The other one doesn't. Gets don't have execution. They just retrieve a value. So we're going to plug in the cast output straight to setting the score of the player. And since we're getting the current score, all we have to do is add a 1. So type in the plus symbol. You can also just increment int. That's just a simple function that increases it by 1. But we're going to do integer plus integer. And we just plug in that value into the score. So now every time this function is called, the score integer in the player class will be increased by 1. And now after that, then we destroy self, which is the target object, because that's the blueprint we're in. So our score should be increasing, but it's still not going to be actually displaying the score. What I'm going to do is make a function in the player class to display the current score. Player object now. We're going to create a function by clicking this. Let's just call it display score. So in this display score function, I'm going to use a function called print string, which is just a debug thing. Before we design a heads-up display with fancy fonts and all that, print string, plug it in, take the score integer, click get score. We can just plug it straight into there. It's going to automatically convert integer to string. Oh, before we actually run this, we made the function, but we haven't actually called the function. We need to call the function inside the target object. So after adjusting the score and before destroying this entire object, we need to do that function. So take another reference from the character, and then now that we created the function, we can just search for the name of the function. Display score. It's right here. Call function display score. And we're going to run this executable wire through that module out the other side. Now let's see what that looks like. It might not be perfect. In the top left of the screen, there's our 1. It's a little bit covered by the Shift plus F1 for mouse cursor. So I'm actually gonna just do something a little bit hacky here. Instead of just printing the score, we're gonna go down a line first. We're gonna do append, which is adding 2 strings together. And we're gonna the first string is just gonna be an enter character. If you just press the enter key, that's not gonna work. Hold in shift, press enter. There we go. So we're gonna append a new line with the score. Now hopefully it'll go down a line and it'll be out of the way of that little shift plus F1 for mouse cursor. So there we go. It's pretty good. Now I want it to be easier to see, like red. There we go. Now let's add a few more of these to the world. So if you press Control W, that's a shortcut to duplicate. Just put a few of these out. I'm going to copy both of these. Control W. Copy all these, Control W. Let me move it back a little bit. So, see what it looks like. 1, 2. So I probably want to take off that debug drawing the line because it's kind of annoying, you know? We used it to figure out if we were drawing the line in the right place, and now we know that we are, and we don't need it anymore. Let's just disable that in the event graph. So instead of when we press going through the draw debug line, we can just move it straight through the draw line trace. We can keep this here for later if we want it. Looks good. Now how about we say we decrease the score if you click and you miss a target. So how would we do that? Well, in the line trace, we did a couple things to check if we were hitting the correct object in order to increase the score. So the first thing we did was make this branch that checks if we actually hit something. So it's true if we hit including the ground or any other actor in the world, this would be true. And then after we did that check, we also checked if the object we hit is the correct type of object, which is a target object. So if we take a line from false, this is going to be what's called if we just shoot into the sky and don't hit anything at all. Let's add a reroute node just to keep that in mind. And we can add a comment. Click the 3 dots, decrease score, because we haven't made the function yet, but we can just do like a little to-do thing. Now, again here, if we hit an object that's not the correct type of object, we want to do the same thing. Let's plug that into the same place, right? So these will merge, that's fine. So whether either of these is called, it'll decrease the score. So how do we decrease the score? Well, it's going to be easier than increasing the score because for increasing the score, we made the function in the other object. So we had to get the player character, cast it. But since we're already in the character blueprint, we already have the score variable right here. So we just get the score. And we're also going to need to set the score. But this time, we're going to take this value and decrease it by 1. So type a minus sign. Integer minus integer, score minus 1, plug it back into score, and set. Oh, also we need to update the player score after that. So take this function here, display score, we can just drag it into here. So we have 0 points right now, shoot the ground, -1 points, shoot the sky, -2 points. Now we get positive points. So guys, I think that's enough for the first video of this little short series. Next time we'll do a little bit more game logic, like spawning the objects on a timer and adding a little button that can restart a round. So let me know in the comments if you need any help with this current video, and I will see you guys next time.